Welcome all, and thank you for joining today's Adabri webinar. My name is Matt Holdstock, and I'll be your webinar host today. In today's session, we will take a look at waste with a webinar titled Insect Bioconversion, Closing the Loop on Winery Waste. In the spirit of reconciliation, the Adabri acknowledges the traditional custodians of country throughout Australia and their connections to land, sea, and the community. We pay our respect to their elders past and present and extend that respect to all Aboriginal and Torres Strait Islander peoples today. I'd also like to acknowledge Wine Australia for providing funding and support for the webinar program via the Adabri Extension and Communication Project. But before we jump in and make a start, a couple of quick reminders for anyone who's new to the Adabri webinar program. If you'd like to provide a comment or ask a question, please click on the Q&A button on the Zoom toolbar, type in your question and click to send it through. We will hold the Q&A session at the end of the presentation, but feel free to send in your questions at any stage. A reminder that also this session is being recorded and a link will be sent through to you later today via the Adabri's YouTube channel. For anyone who's just joined, welcome. Today's webinar topic is Insect Bioconversion, Closing the Loop on Winery Waste. And it is with great pleasure to welcome our presenters today. And we have two presenters. Today's webinar will be co-presented by Chris Malcolm and Tammy Schutz. Chris is the co-founder and operations manager at Mobius Farms. Chris has held technical and senior management roles in engineering, logistics, supply chain, business improvement, and reliability consulting within the oil and gas, dairy, local government, and wine industries. Chris now applies those decades of experience to applying insect technologies to organic waste valorization. Our second presenter will be Tammy Schutz, and Tammy is a viticulturist from the Schutz in the Barossa Valley. Tammy's a multi-generational Barossa Valley grape grower, and along with her husband Stuart, have supplied grapes for super premium wineries and winemakers for decades. They are active members of Sustainable Wine Growing Australia, and they are ambassadors for improving sustainability and resilience within the grape and winemaking industry. So if you're ready to make a start, Chris, I'll get you to share your screen.
Okay, can you see that?
Okay, over to you.
Thank you very much, and good morning, good afternoon, good evening, wherever you are listening into this webinar. It's a great opportunity for us, and thank you for that opportunity to share with you today the outcomes of some recent work that we've done in the bioconversion of grape marc and the possible potential of this process as a means of valorising winery wastes. Just by way of acknowledgement, I'd like to say that this work has been made possible with the assistance of Treasury Wine Estates, Barossa Wine, and Schutz Barossa, who you will be hearing from shortly in Tammy's participation. Let me just context what we're about to talk about. This presentation is very much an overview of our work to date, and whilst we've got lots and lots of data from the work we've done, I'm not going to try to confound you with the excessive tables and numbers, but rather just present an overview. I think through Q&A and follow-up, we can get down into more details if that's of interest to you. We're currently compiling a very in-depth report, which we're happy to make available to interested parties when that is completed. So, size of the issue. In 2024 vintage, Australian wine grape production was reported at 1.43 million tonnes. Now, that winery waste that comes from that grape production is largely comprising grape marc and lees, and generally estimated to be between 15 and 20% of this grape production. So that equates to around 240,000 tonnes. To give you a bit of a visual on what 240,000 tonnes of grape marc and seeds and lees and so forth that looks like, take your national stadium, in this case, let's say Adelaide Oval, and it would fill that oval to a depth of 20 metres. So that's covering the scoreboard at Adelaide Oval. So it's quite significant, that volume. The current disposal practices for that winery waste includes things like sending it off to distilling, but you're still left with quite a volume of waste. Livestock feed gobbles up a bit more, but composting is probably the area that commands most of that processing of the waste. But these practices, these current practices, have their impacts. Current composting practices, for instance, contribute significantly to greenhouse gas emissions, and they require large areas of land. And when you consider that fertilizer costs are only increasing, the question becomes, is there a better way to manage these winery wastes? At Mobius Farms, we use insect bioconversion to close the loop on these organic waste streams. We use an insect called the black soldier fly, and specifically its larva, to convert organic wastes into alternate sources of protein and also a high quality fertilizer. The protein is used in pet food products and treats, and the fertilizer is returned to market gardens for growing more food. With this natural technology, we capture the nutrients that would otherwise be lost to landfill. So, can we apply this technology to the treatment of winery waste? The proposition then becomes, how might we recover the nutrients in grape marc more effectively for vineyard applications? Using the insect bioconversion processes, we tested the capability of the BSFL, black soldier fly larva, to effectively and efficiently recover those nutrients from the winery wastes. Specifically, our research interests were, do BSFL bioconvert the grape marc? What are the properties of the resultant frass, or the manure from the larva? And is the frass a suitable fertilizer or soil improver for vineyard application? Running through the methodology of what we did for these tests, it followed a fairly standard sort of procedure. Firstly, we prepared a bunch of grape marc substrates or diets for the larva to get into. There was a control, obviously, to test the other ones against. But the grape marc from 3 varietals, Sauvignon Blanc, Riesling and Shiraz, were collected from Treasury Wines during the last vintage operations. These substrates were then made up in concentrations of 25% grape marc, 75% control, 50% grape marc, 50% control, 75% grape marc, and 100% grape marc. So we had 5 different substrates for each of these varietals. The larvae were then added to these substrates and their growth parameters monitored and recorded. And then samples from the larva, the frass, and the substrates were all then recovered for further analysis. And we analysed for their physical and chemical characteristics. It's just some pictures of some of the things going on. Here you see the grape marc dispensed from the various bins at the winery. This picture here is typically what you see in the trays as it's being bioconverted. We use these sort of trays that you can see here of that size, and typically what you'd end up is a fat little larva with the remnants, and in this case you can see seeds and some grape skins left behind. Similarly, some more photos. Here you can see the larva getting into the substrates further on and the resultant. Here is a picture of the larva once they've been dried, ready for processing. So, on to the results. This chart displays the data relating to the larva growth rate. It's on a weight basis. And the main takeaway here is that the larval growth rate was relatively consistent across the different diets, up to including 75% inclusion rate of grape marc. The larva on the 100% grape marc diets, the yellow, blue, and red chart trends here, had the poorest growth, and these were obviously the 100% grape marc diets, where the nutrition value in the diet was probably quite poor. whereas these other ones which contained a portion of the control that we used to feed our larvae had a better growth rate. But you can see a deteriorating growth rate as you go from the control through the addition of the grape marc. However, from a commercial viewpoint, anything above this line here, 100 to 120 milligrams, would be considered acceptable economically for breeding and growing of the larva. Getting on to some of the KPIs, material reduction rate is a measure of how well the larvae have reduced the overall volume of the material. In other words, the effectiveness that they've got into the diet. Across all diets, even the 100% grape marc diet, the larvae were able to reduce the weight to volume or volume of grape marc material by more than 45%. So it's quite a very good result, we feel. Even in the case of the 100% red grape marc substitute, right at the right-hand side of this chart, the larvae were able to reduce the marc to under 40% of its original weight. Now, that in itself is quite an achievement, but when you consider that this reduction took place over a period of 5 to 10 days, not months, it makes it even more significant. Another measure of performance is the bioconversion ratio, and this is used to measure the efficiency of how the larvae grow on the various waste streams. Basically, it's a measure of how much feed was consumed to produce 1 kilogram of larva on each diet. Here, a lower number indicates a more efficient bioconversion of the substrate. In other words, less feed to produce the same quantity of larva. A higher number, like that recorded for the 100% Shiraz diet, indicates a poorer bioconversion performance by the larva. But we found that the larva bioconversion efficiency was relatively good for diets up to 75% grape marc inclusion when compared with the control diet. And you can see the relative performance between the various diets up to the 100% mark, where it really consumes a lot of extra feed to get the same amount of larva biomass. What's really interesting in terms of this particular trial and project was to test or to find out what the macronutrients in the resultant products were. Because remember, we're trying to find out whether the frass particularly was going to be a suitable fertilizer or feedstock for a fertilizer out of the process. So the following charts examine the concentrates of macronutrients in those various frass samples. Along the bottom axis of the chart are the different grape marc diet samples, unprocessed 50% and 100%. Obviously, we have intermediary results as well. This first chart is for Sauvignon Blanc grape marc. The number on the vertical axis is percentage concentration on a dry matter basis. So here we have the key macronutrients that people would be interested in: nitrogen, phosphorus, potassium, calcium, sulfur. And generally, we found that compared to the unprocessed grape marc, the concentration of macronutrients increased with the increasing concentration of grape marc in the substrate, particularly with nitrogen, phosphorus, potassium, and sulfur, perhaps less so with calcium. And this is because we found that the calcium concentration goes to the larva in preference, as opposed to the phosphorus and the potassium, which accumulates in preferentially towards the frass. We found similar profiles of these macronutrient distributions in the Riesling grape marc diet samples. Again, with the Shiraz, this chart shows the total macronutrients that we found in the frass from the Shiraz grape marc diets. So you can see nitrogen increased to about 3% in the 50% Shiraz grape marc, up from just under 2% in the unprocessed grape marc. So that's a pickup of about 50% increase in concentration. Again, we see that the accumulation of potassium in the frass, which is likely due to the larvae not requiring potassium for their growth. So you can see that the potassium jumps up a bit in the total number of macronutrients in that particular frass sample. Here we can see a similarity between the unprocessed Shiraz grape marc and the frass sample derived from feeding the BSF 100% grape marc diet. You can see the pickup in the various concentrations of the macronutrients. What would also be of interest would be to see what was happening with the soluble macronutrients. In other words, that portion of the macronutrients that is readily soluble and available to mix in the soil. The soluble are more readily available to soil microbes, roots, and plants. Here again, we see the concentration of the macronutrients have increased from the unprocessed to the frass products compared across the various diets. And we can see that the levels of phosphorus and potassium in the resultant frass products are less in terms of their total concentration than in the totals, obviously. But this would be more in line with what we might find in your commercially available fertilizers. So that was quite encouraging. And again, with the Shiraz grape marc diet, there's similar outcome. Not a big difference between nitrogen totals, but a sizable decrease in the soluble phosphorus, potassium, and calcium concentrations compared with the totals. I guess the wash up on this would be that it's great to get involved and hear from technical vineyard personnel who would have a better understanding of the various differences between totals and solubles and how that might apply in terms of the application of something like an insect frass. Another area of interest is around what happens to the acidity. We know that the unprocessed grape marc has quite a high pH value, and you can see here that we measured it at around about 4%, which is quite acidic. But in all diets, the bioconversion processing resulted in an increase in the pH or a decrease in the acidity, such that we achieved neutral pH levels or slightly basic, alkaline, in the resultant processed products. So that was a good result that we measured. And if we have a compare, this is a little bit of a busy slide, but if we compare the results with a commercially available fertilizer, we find that the macronutrients, such as the nitrogen, phosphorus, and potassium, and the BSF frass match those found in something like Nutrog's Rapid Razor, particularly in nitrogen and potassium. The levels of phosphorus, calcium, sulfur are higher in the commercial product, but I guess if you were making up a blended fertilizer, you could find ways or manipulate your feedstock in the bioconversion process to make exactly the same. The smaller nutrients we found were in similar concentrations. In summarizing the outcomes and findings, the key takeaways would be that the total NPK concentrations in the BSF products approximate those or approach those found in a commercially available fertilizer. Nitrogen, phosphorus, calcium, magnesium, and sulfur accumulate in the larva, whereas the potassium tends to concentrate or accumulate more in the frass. The pH of the untreated grape marc was measured quite acidically at 4, whereas it neutralized after the bioconversion process. The organic matter of the frass samples is greater than that previously reported in grape marc compost, so that was encouraging. Total carbon was greater than 50%. The carbon to nitrogen ratio moved from over 20 in the untreated marc to below 20 in most frass samples, and that's encouraging too for soil health. And generally, the frass products met the Australian standard for composted products. In closing, let me say that the general benefits of insect bioconversion and resultant products are that it's an accelerated process for composting organic matter. It increases or concentrates the essential nutrients and organic matter in resultant products. It provides beneficial microorganisms. It provides a source of carbon for the inclusion in the soil. And the presence of chitin, because it emanates from an insect, in the resultant products has been proven to improve root and plant health and increase disease resistance. And another takeaway is that heavy metals, if they are present in the substrate or the diet, are shown to concentrate in the larva and reduce in the frass. So this is a way of actually removing them from the frass product, but then you've got to deal with it in the larva product. I'll hand over now to Tammy, and she'll complete the presentation. Thank you.
Thanks, Chris. As mentioned previously, I'm a generational vigneron with an interest in sustainability. And with one of the most significant waste streams in our region being winery waste, I thought it was an interesting opportunity to use black soldier fly larvae to try and capture the nutrients in this waste in a more efficient way and with less carbon emissions than composting. So I connected with Mobius Farms and we received funding through Barossa Australia and Wine Australia and support through Penfolds Evermore to undertake a vineyard trial, which we began in autumn 2024. So next slide, thanks, Chris. So baseline soil mineral tests were taken prior to the trial's commencement and are being repeated annually. So I broadcast the frass at varying rates between 0.25 to 1 tonne to the hectare over 1 hectare of vineyard using Neutrog Rapid Razor at 1 tonne to the hectare as the commercial comparison. I then sowed a clover medic mix mid-row after the frass application. We did have an extremely dry growing season and a very late start to the rains in autumn and winter. So the cover crop was sown quite late and it didn't thrive due to the dry season. So it didn't provide me with a means by which to measure the difference between the trial variations. Next slide. So we didn't have that method to measure differences, but we have undertaken soil microbial testing in the spring, which we'll continue to do annually. Very interested to see what's happening biologically. And in addition, PDL samples were taken at flowering and sap testing throughout the growing season. At this stage, it's very early in the process and in the trial to draw conclusions, but there's certainly some promise showing in relation to using frass as a soil addition in the vineyard. As Chris mentioned, the black soldier fly larvae processing neutralises the acidity of the marc, which I think is quite significant considering you don't need to compost it for months at end. The other thing which is of interest to me, especially in these drought years, is the frass's ability to increase soil moisture holding capacity. It's also a slow release fertiliser, so we're always conscious of excessive vigour and shading of fruit and affecting fruit quality. So we don't expect that to be an issue with frass because it has that slow release capability. Another aspect is the presence of chitin in frass and its ability to enhance the plant's defence mechanisms. So that's in relation to disease resistance and promoting microbial activity. It's of great interest to us. The other thing, we're also looking at potassium levels, nitrogen levels within the frass, and we're conscious of ensuring that the potassium levels are not excessive, as obviously this can affect wine stability. So at this stage, we're keeping a close eye on that, and we feel that maybe frass might suit certain soil types better than others. But we can, of course, like Chris mentioned, alter the substrate to end up with a frass that suits our needs better. Next slide, thanks, Chris. So there's plenty of room for further research. We're looking into using frass in a compost tea, and also applying as a root drench, which definitely has promise. We're also collaborating with the company named Insect Biotech. They're beginning frass trials in Europe in 2025 in various countries throughout Europe. So we will continue to share our results with them and collaborate and work towards more refined results. Ideally, this trial will continue over the next 5 years so that we can identify significant changes within the soil microbiome. But we do need more scientific analysis around frass to understand its suitability as a vineyard soil addition. But it's a complex topic, and more research is required at this stage. Thank you.
Thanks, Tammy, and thanks, Chris. That was great. Yeah, very interesting technology. And yeah, it looks very, very, very promising. There's been a couple of questions come through, so I'd just like to remind everyone who's online with us, if you have a question or a comment, feel free to type into the Q&A and send them through. So the first one's quite a long one, but essentially the question resolves around about the treatment and storage of marc for a year round use. So how long can you store the grape marc for, Chris, before it needs to be used?
Yeah, good question. So for this particular work that I've just presented, the grape marc was only around about at most a month off the press. So that was quite recent. However, previous work we had done about 12 months ago and so forth had some grape marc that was at least 6 to 9 months old. Beyond that, I'm not really sure, but certainly we've still got samples, untreated samples from 12 months ago that we could run through. I don't think it would make much difference, really. We know that the larvae have a greater appetite the more, or the older and more fermented the product actually is. So that, I'm not sure if that answers it, but it's something that we could certainly test.
Okay. There's another one come through. I'll just read the question. I think I understand it. How do we do bioconversion in our own businesses? Perhaps that's more about supply of the larvae, perhaps, or is it?
Scalable solutions.
Yeah, well, I guess this is something I guess that the insect industry is really sort of wrestling with is scalable, or how to scale to meet the needs of individual companies and so forth. Obviously, each company probably doesn't want to set up its own insect bioconversion facility, but there could be a role for a centralized processing arrangement should those companies wish to engage. I guess it's something that we could comment on if we knew the circumstances of the particular company that was interested in doing it.
Okay. Another question is, do the heavy metals that you referred to, do they have an effect on the health of the fly larvae?
It doesn't appear so. It's from what they're fairly low concentrations anyway, and what we have found is that the larvae are very, very resilient to a lot of unfavorable circumstances. They survive in heats up over 45 degrees, very high humidity, low humidity. They can still have an appetite below 15 degrees centigrade. So they're fairly resilient, and we've put some pretty ordinary sort of stuff in front of them to chow down on, and they seem to be they still seem to grow satisfactorily.
Okay. Someone's taken it. Just asking about, is there a risk of a black soldier fly plague?
One of the beauties of the black soldier fly is that the adult fly, in other words, the mobile version of the insect, has no interest in eating. In fact, it doesn't eat at all. It just survives for about 7 to 10 days to breed. So once it's bred, the female will seek out something to lay the eggs on, and that something has to be something that's rotten or fermenting. It doesn't have an interest in any product that might be whole or fresh. So, and they are fairly well endemic to all parts of the world now. So I would say no, there's not, even though obviously in a production sense you are intensively farming them and creating populations that probably outnumber those that you'd find in the wild. But particularly in temperate climates, they won't survive because they are a tropical species. So they'll quickly die if they get out in tropical situations. Well, I think that's a different story. But again, I go back to the fact that the fly has no interest in going from one food to another, so it doesn't spread any disease. And so the biosecurity risks are very, very low.
While we're talking about regions and different environmental conditions, there's a question about, hi Chris, can you talk about your investigations into the development of this industry in other countries, for example, South Korea?
Yeah, certainly from our experience, the South Koreans are very well advanced in their insect industries, insect breeding industries, so much so that the supply chains there have matured to the extent where you have companies only producing fly eggs, others only producing neonates, others only growing out the larva, and then at the high end you've got other companies fractionating the various products out of the larva and the frass and so forth for ongoing nutraceutical, pharmaceutical and medicinal type products. Europe and US are probably the larger producing entities, although certainly from what we know, China is well on the move in this space as well.
Okay, there's been a few more questions come through. Sorry, I'm just, does frass and dried larva have a best by date?
Not to our knowledge. The larvae obviously are initially frozen and then we dry them for further storage. Once the moisture is below 5%, we found that the shelf life of the larva and its products are almost indeterminable. The frass doesn't appear to have a shelf life, and again is best stored in a dried capacity. So as soon as you eliminate most of the moisture, then both of the products and so forth will have a good shelf life.
Okay. Is there any research indicating that the larvae from grape marc will have health benefits similar to grape seed extract supplements?
No, can't comment that specifically, although we do have some work going on at the moment at one of the local universities where they are testing the antioxidant and antimicrobial properties of larva oil that has been extracted from larva-fed grape marc, but we're waiting on the results of that.
Okay, just a little bit further on in that space. In terms of the macronutrient measured from the frass, could you clarify if there was a control and what the macronutrient are between the control and the treatment groups?
Yeah, I didn't have that up on the chart, but essentially, depending on so it goes back to what the originating diet was. If you've got a certain level of macronutrients in that in that control diet, then they will also be accumulated or concentrated in a similar way to we saw in the grape marc, in the frass or the larva, respectively. So I think and then this leads us to believe that we can control the outcome of the macronutrients in the resultant products by manipulating the feedstock that the larvae are dieting on. I'm not sure if that answers the question. But like whoever's asked the question, I can certainly provide information that compares the control with the grape marc diets.
Okay, I think you've had some information on the screen there for people to contact either Chris or Tammy if people want to get in touch. I'm sure they're more than welcome to do that, and they'll get in touch. Another question here, I guess thinking about the practicalities. So if you were designing the ideal configuration of marc preparation, what would this look like, and how long from the start of the introduction of the larvae to a vineyard prep being available?
So the process of actually bioconverting grape marc could be done continuously, but from going from the placing the neonates on the feed to when a frass is available is a matter of 10 to 12 days only. And during that time, it's progressively being bioconverted, obviously. So the process would more likely look like a continuous feed of neonates being fed or being placed onto a continuous stream of grape marc or prepared grape marc.
And Chris, you'd supplement that with food waste, wouldn't you? You wouldn't go with 100% marc, potentially 50 to 75% marc and the remainder with food waste?
Correct, because what I touched on in the presentation was the fact that the 100% grape marc larvae don't thrive. They continue to grow. We didn't see them maturing. So there's a couple of things there. From an economic processing viewpoint, you want your larva to get to the size as quickly as possible so that you can recoup the benefits of that alternate protein or the oil from the larva as quickly as possible. So yes, you would mix it with some other substrate to enhance not only that bioconversion rate, but also the outcome, the nutritional outcome of the larva. The outcome in the frass doesn't seem to make a lot of difference. But the economics in all of this would point to the fact that you need to extract the value of the larva as well as the value from the frass to balance the costs associated with processing in this manner.
All right, there hasn't been any more questions come through. So what we might do is we might just finish up there. So just like to thank Chris and Tammy for taking us through the work on black fly larva insects. I think it's a very novel approach to accumulation, for the bioconversion of winery waste. I'm sure everyone who attended today got a lot out of the session, including the Q&A session. I'd just like to thank you, the audience, for logging in today and taking part. And I'd like to remind you that, as always, you will receive a link to the recording of this presentation, which will be available on the Adabry's YouTube channel within the next 24 hours. So thank you again, and I look forward to seeing you at the next Adabry webinar. Thanks a lot. Have a good day.
Thank you.
Thank you.